Today we will talk about Su-27. First, we will discuss the characteristics, features. At the end we will discuss its two brothers, the Su-33 and the Chinese J-11. Angels of the Sky channel with you, let's get started. Su-27 is a four-generation multi-role heavy fighter. One of its first serial modifications is called Su-27S, where S is serial. The aircraft has 10 suspension points, an impressive arsenal, a 30mm cannon mount and, in addition to a radio locating station, which is very important, an optical locating station, which we will talk about later. The aircraft is equipped with two AL-31F engines with afterburner thrust of 12,500 kilograms of forces each, which is enough, despite the largest mass of the aircraft in its class, to accelerate it to decent speeds, but acceleration qualities still suffer. Notable about the Su-27 is its aerodynamics and control system. Many people know that this plane is said to be aerodynamically statically unstable. But in fact, its stability in the angle of attack of the flare to neutral at most CGs is done to reduce the losses of lift for balancing, since on a stable aircraft the force on the stabilizer is directed downward and is subtracted from the lift of the aircraft. I agree, it sounds very scary and incomprehensible, so let's demonstrate all this to you more clearly using the example of a stable aircraft. Suppose the F-4 Phantom has a lift created by its various parts and a center of mass, and you can already see that due to their location the aircraft even has a zero angle, the attack will be in a kind of imbalance. The balancing force created by the stabilizers will maintain the balance, and when reaching a larger angle of attack, the aircraft will firstly need a greater balancing force, which will lead to a loss of lift, since all the balancing force spent on balancing is subtracted from the lift. Secondly, the balancing resistance will increase, since the stabilizer will have to be deflected strongly. Now let's look at the unstable Su-27 aircraft, and you probably noticed the location of its lift and center of mass. That is, even with a zero angle of attack, it will be balanced. It does not require additional counterbalancing force, and for the same weights, this can also be replaced, and when reaching the same angle of attack, it will need less counterbalancing force. It turns out that the balancing resistance will be less and the loss of lift will also be less. This is the main advantage of unstable aircraft, and it would seem great, but if it were not for the computer provided in the remote control system, then the aircraft would simply be difficult to control. Just in flanker, the remote control system controls all channels, but the real remote control is carried out only in the pitch channel, and there is a mechanical connection in the roll and direction channels. The fighter is maneuverable and easily controlled largely due to the remote control system. It provides the Su-27 with artificial stability, controls the wingtips by deflecting them in an optimal way when maneuvering, and also with the help of a limiter, which does not allow going out to exorbitant angles of attack and exceeding the overload. That is, you fly with full tanks and pull the handle all the way towards you. The plane will develop an overload of a maximum of 5G instead of 9, which will save you from damage or even destruction of the glider. The limiter limits the pitch and roll of the stick with special rods that can be reset if the pilot needs it. You might think that this is how the Su-27 performs a Cobra, but no. The remote control system has a standby mode called hard link. In this mode, the computer stops performing any correction and the pitch movements of the RUS are transmitted directly. The gear ratio can be changed. For example, at an air show, the pilot turns on the hard link before performing the Cobra, after which he turns it off and continues aerobatics as usual. Those who know at least something about the Su-27 have probably heard that one of its advantages is an integrated aerodynamic circuit, but there are drawbacks to such a solution. The integrated circuit is a smooth conjugation of the wing and the fuselage, in which the fuselage has high bearing properties. Such a glider at supersonic is worse than that of aircraft with a traditional scheme. For example, such as the MiG-21, and also generally does not have high dynamic characteristics. The flanker has root swells that create vortexes that increase stability at high angles of attack, as well as reduce rebalancing at high speeds. Instead of separate ailerons and flaps on the Su-27 installed flaperones, they perform both roles. Moreover, they are controlled by a computer and are deflected at optimal angles when maneuvering. The Su-27 is a very maneuverable aircraft and, despite the largest mass in its class, as I said at the beginning of the video, it has high-speed indicators, but it suffers from the same high mass and integrated circuit. In comparison, for example, with the F-15C, the Su-27 really wins in maneuverability, but not in some speed ranges, but due to a smaller loss of speed on unsteady turns, that is, twists, while in a steady turn F-15 can twist Su-27 due to its thrust-to-weight ratio. Yes, overclocking F-15 is much better. I must say that the controllability of the Su-27 is good and pleasant. But for a normal flight, and in combat, let's say the F-15C is controlled more clearly and faster, especially in pitch where the Su-27 has a slow response. At high angles of attack above 26 degrees Su-27 is very stable, but roll control is almost completely lost, even though the remote control system is steering the rudders. One of the features of the dynamics of this aircraft, the behavior in an inverted spin, from which it is quite difficult to get out. It happens with unfavorable alignments and sometimes with inaccurate control, where even the remote control system does not protect you from such a mode. Now let's talk a little about our radar station. So the N001 locator on the Su-27 is powerful enough and sees targets well against the background of the Earth. Although the Doppler filter separates targets with a radial speed of less than 200 km height, this means that we will not see helicopters flying strictly towards us at a lower speed, let alone targets flying at an angle. The range at which the radar will be able to detect an aircraft flying at us with a size of about F-15 is about 80 to 100 kilometers, which is more than enough considering that a less effective launch on a maneuverable target can be carried out from 15 to 20 kilometers. This is at best the farthest missile in the arsenal Su-27 R-27RR. In general, a long-range missile battle is a battle only a few kilometers further than a close one, even with the use of the most advanced air-to-air missiles. This gives vast expanses of Su-27 to show off their capabilities in close combat, because the R-73 melee missiles and the helmet-mounted target designation system, coupled with maneuverability, can confidently win close combat against any opponents. But the F-18 with its helmet-mounted target designation system and the AIM-9X will be roughly on par with the older Su-27. In long-range group combat, American aircraft outperform the Su-27 due to missiles with an active self-guidance head and due to the best locators. Su-27 can only launch missiles at one target. The designers meant to carry out real combat work with guidance from the combat control operator. In this situation, the potential of the aircraft is revealed in the outcome of the battle with the F-18 and F-15 aircraft already depends to a large extent on the tactics and training of the pilots. It is worth adding that the Su-27 has data exchange between the optical location stations of the fighters. So, an optical location station, what is it and what is its main advantage? We will not analyze in detail the principles of operation. I will not say only that this is a heat direction finder and a laser rangefinder, which in a compartment give us a system invisible to the enemy, that is, unlike a radar station, which is not bad for us. The optical location station does not give any radiation except for the laser one, that is, the one that the enemy simply cannot detect. Also, he will not be able to track the launch of the rocket, and I'm not talking about target acquisition, but this system has a huge drawback. It lies in the fact that it is not as big-eyed as a radar station, even in terms of numbers, the maximum detection range of the same fighter. Taking into account what will be favorable conditions, and it will fly at maximum thrust of only 50 km against 80 to 100 km at the radio location station. In addition, the worse the meteorological conditions, the worse the efficiency. Well, the capture itself will also fail much more often, and the missiles that we can use in conjunction with this complex, we have only two R-27T and R-27Et. Now we got to Su-33. Let's first have a few differences from the Su-27. The first is the PGO, or the front horizontal tail. It is designed to compensate for the resulting stability of the airframe and create a special vortex that increases the wing lift. The second is folding fenders and stabilizers. The third is two-section flaps and floating ailerons instead of flaperons and three-section wingtips. By the way, the stabilizer on the Su-33 does not deviate differentially during roll control. The fourth is the landing hook and the brake parachute is removed, plus the equipment for landing on the aircraft carrier has been added. Fifth is the strengthening of the structure of the landing gear. The front pillar is now with two wheels instead of one. Sixth, added a refueling system in flight with a boom. Seventh, 2 suspension points have been added and now there are 12 instead of 10 as on the Su-27. The last 8 point, the engines on the Su-33 have a special mode with a total thrust increased by more than 600 kilograms. Su-33 is really very different in control and characteristics from the Su-27, it is almost a different aircraft. The heavier carrier-based version of the fighter is certainly less maneuverable and accelerates worse. But if you turn on the special mode, you can get almost the same dynamics. Of course this mode is intended for takeoff from an aircraft carrier with high load. When you're in a dangerous air combat situation, all is fair. In terms of landing speeds, the Russian Decker is quite at the level of the F-18 and F-14, a little slower than the Hornet but faster than the Tomcat. By the way, it is quite easy to board an aircraft carrier to get on the desired tether, and what is also important, the Su-33 has an automatic cruise control, which is quite convenient if you get used to it. Finally, a little about the Chinese copy of the Su-27 is J-11A. By and large this is a copy of the drawing, only the whole cabin is in Chinese. Also added are front lights like NATO ones and many colors of different Chinese units, and the Chinese can also use R-77 missiles with an active self-guidance head. That is, they do not require target illumination at certain distances. I have everything. Thank you all for watching. If you liked this video, please like it and write a comment. Subscribe to the channel Angels of the Sky.